So remember that time we took the derivative of two functions of x. We called them u and v. It's like f of x and g of x. But we had two functions. It's called the product rule. Remember those days? Fun times. Fun times. And the derivative of this product was what?
U prime v plus v prime u.
U prime v plus v prime u. Yeah?
Yeah.
Now, if we integrated both sides, brace for impact, take the integral of both sides, and the integral of all that is basically, you know, the integral of this plus the integral of that. Yeah? You with me? And what's the integral of the derivative of u times v?
uv.
Yeah, u times v. So this, the integral and the derivative undo each other. This is just u times v equals. And now this here, let me make a side note to make sure we're on the same page. Side note. The integral of 1 with respect to x is what?
0.
It's 1.
If you raise
It's
1,
1x.
then it
It's 1x.
Oh,
So this is equal to x. So basically, you could say the integral of dx is x. So does this sound like the integral of the derivative is x? So I'm trying to get you to think of dx as the derivative of x.
Yeah.
We've been saying with respect to x.
Yeah.
But can you treat dx as the derivative of x?
The derivative of x? What? Yeah, repeat that.
Think
I mean,
about-
duh, that makes sense.
So think about dx as the derivative of x, right? Because look at this. If we take the integral of dx, we get x. So the integral of a derivative is the thing.
Mm-hmm.
So it's almost like the integral and the d cancel each other out, kind of thing. So the integral of dx is x. So this integral v is a thing, but the u prime, can we think of u prime as du?
Yeah.
Because isn't u prime the derivative of u? So think of this as du plus integral of u.
V prime, dv.
We'll call this dv instead of the derivative of v or v prime.
So wouldn't that just be...
So now, what we'll do is we'll subtract.
U, and then divide both sides by u.
We're going to subtract v du on both sides. That's what we're going to do. And then so the integral of u dv is equal to uv minus the integral of v du. There we go. That's what I wanted out of life. Whew. That's integration by parts, ladies and gentlemen. That's our formula. The integral of u dv is equal to uv minus the integral of v du. Kind of rolls off the tongue. Say it a couple times and you're like, yeah, I got that.
No.
But then you have to think to yourself, well, what the hell does that even mean? And then so we'll get to that. So let me put an example up there.
No, but wait. If you're taking the integral of u times the derivative of v, then why wouldn't it just be the integral of u times v? Or not even u times v, but what happens to the v? Why wouldn't the v just vanish into non-existence? Because if you take the integral of the derivative of something, then you're left with something.
So these are two different functions, though. Let me put an example up there and see if I can make some sense out of this. So we're going to take the integral of x times the cosine of x with respect to x. could we do a u substitution?
Yes.
What would u be?
I don't know. I feel like maybe.
No, because there's no derivative in it.
Yeah, we don't have a thing and its derivative.
You have to have a thing and its derivative in the problem in order to do a u substitution?
Yeah. That's all the stuff we were doing this week was that. Where you had a thing and its derivative both present. But if you don't have a thing and its derivative both present, right, there isn't like a product rule for integration. I mean, the product rule for integration essentially is this, because this is the product rule and we integrated and rearranged it. So this is kind of like the product rule. And so what we do is we say, hey, I'm gonna pick a u and a v, and then we're gonna have a du and a dv. So that'll be the setup. So it's kind of like a double u substitution. But what we're gonna do is we're gonna select, so we have two functions here. We're going to select one that if we take the derivative of, it's going to get easier. And the other one is going to be our, right, this is what we're dealing with. Integral of u dv. Integral of u dv. So we want to pick something that if we take the derivative of, it gets easier. And something that we can take the integral of, and it won't necessarily get harder. Because we take the integral of this, and we're just going to get a sign or a negative sign or something like that. So, just follow me. So, let's select u to be x. What's the derivative of u?
1.
1 dx. And now we're going to call this my u, and this we're going to call it dv. So my dv is the cosine of x dx. If I take the integral, if I integrate this to go back to the original v, what's v going to be equal to?
Negative sign. Oh, the integral. Yeah.
Yeah. Sine of x. We okay? Mm-hmm. So I'm giving you training wheels on like, you're always going to have a u, du, v, dv, and then we're going to try to match it and plug it in somewhere. But now, so if we do this substitution, well, yeah, this is u dv. I shouldn't erase that. I feel silly now. So this is the integral of u dv, which is equal to uv minus the integral of v du. So let's plug that stuff back in. What's uv?
X sine x.
X sine x minus the integral of, let's plug in, what's v du?
Cosine x dx.
No, v is right here, champ.
Oh, du. Oh, sorry.
So v is sine of x.
Dx.
Du is dx. This integral has been made mo beta. Because this, impossible. This, I got that. And so now, well, let's do this here. The integral of sine of x with respect to x is what?
Negative cosine.
Yeah, so actually we have this negative sign. So it becomes, what, plus the cosine of x? And then we can throw up a plus c.
Oh my gosh, it's so long.
But it's pretty.
Well, actually, here's the problem.
Well, I mean, it's not
This was
long.
notes. That's not that bad.
So much more longer.
So much more longer.
Yeah.
It's just regular.
You can come up with a better way.
Okay.
I'd love to hear it.
Let's see if we can whip through another one. Integral of
Sorry.
x e to the 3x dx. So we want to simplify this. We want this to go away. We'll make that x. Derivative of that is dx. And we'll make this our dv. And the integral of this damn, we're gonna need to do a U sub. Or you can just imagine, we can guess. If you take the derivative of this, it's that times the derivative of 3x. So the 3 comes down. Can you guys see that? It's a little brain word. Take the derivative of this with your brain and see if you get this.
Okay, so bring the 3.
2 over 3 is 1. So that would
No, I don't get that
be, that would be
at all.
4x.
Yeah. No,
Wait, what?
I really don't.
Because-
Remember the derivative of e to the stuff is
Well,
e to
okay.
the stuff
right.
times the derivative of stuff.
which
So-
is 3 times 1/3 is 1, so it's e to the stuff.
Yeah?
Times derivative.
I get that.
Word. So now let's plug it in. This is the integral of u dv is equal to uv minus the integral of v du. We can plug that in. uv is
X 1/3 e to the 3x.
minus the integral of v du.
Dx.
And now this is easier because it's not a product. And so you can actually do that. So I would encourage you, for homework, take the derivative of this and see if you get back to here.
Wait.
You want to finish it? It's
Yeah.
lunchtime.
Finish it.
Okay, so it's lunchtime, so if you want to leave, you may leave. Oh, no, you can't. Let me give you practice for integration by parts. Probably has an answer key on the back. Okay, there's no way in the flames of Hades that you're gonna finish this whole thing, but have at it. Have at it. And if you want to see me finish this, then we'll go over time. So the integral of this, let's pull this 1/3 through so it's not scary. The integral of e to the 3x, didn't we just do that?
Yeah.
So the answer to this is going to be another 1/3 e to the 3x. So 1/3 x e to the 3x minus, this is going to result in 1/3 e to the 3x, and we have another 1/3, so it's going to be 1/9 e to the 3x plus c. And also I would say, so the main homework I want you to do is take the derivative of this and see if it takes you back. Right, check your answers. Check these answers. Take the derivative of this and see if you get here. Take the derivative of this, see if you get here. That's for real, your homework. And then this worksheet is like, if you got some more time to just take a crack at it. And we'll continue this worksheet in class.